So hi everyone. So we'll start with the second session of this basic mathematics that we are discussing. So today we are going to continue with the discussion on functions and series. I think just to recall, right, in first session we were covering the algebraic identities and the binomial theorem, including binomial simplification. That is what we have covered in the session 1. In the session 2 we are going to look at the series, some more types of series, as well as specific types of functions. Okay, so we'll start with the discussion. So the first we'll look at what we call as the arithmetic progression. So arithmetic progression, right, we will be usually getting it while solving problems in say maybe moment of inertia or center of mass location. I mean in mechanics part, right, we'll get these arithmetic progression applications. Okay, usually we'll have the sum of n terms formula, right? That is what we'll be looking at. Okay, so what is an arithmetic progression? First of all, even this can be there in gravitation chapter also. We can have some questions where the AP formula will be used. Even in +2 electrostatics also we can have, magnetism also we can have. Okay, we'll be able to look at it when we go to the specific problems. But here, what is an arithmetic progression? If you have a sequence of numbers which are having the common difference to be the same, which means what? Look at it, we have numbers 1, 3, 5, 7, 9, 11, like that. So from one number to another number, 1, 2, 3, when you move, what is the difference? 2. 3 to 5, when you move, what is the difference? 2. 5 to 7, when you move, what is the difference? 2, like that. Okay, so an arithmetic progression, right, we can generally express it like this. How do we express it? If we have a as the first term, right, then the second term will be a plus that common difference, third term will be a plus 2d. Like that, if you want to have the nth term is going to be what? A plus n minus 1 into d. This is the expression for the nth term of the arithmetic progression, where what is a? A is the first term, the common difference. Okay, and the other thing is the sum of n terms of arithmetic progression. So this is what will be important for us in terms of solving questions in mostly physics. You will not have this kind of a thing being applied in chemistry. Maybe couple of problems, not sure, but we'll have definitely questions where we are going to use this sum of n terms formula in physics. Okay, sum of n terms will be equal to n by 2 into the last term plus first term. What is it? N by 2 into, if you want to represent a1 as the first term and an as the last term, right, what is a1? A first term. Nth term is what? A plus n minus 1 into d. That is the nth term, right? So what will be the overall formula? N by 2 into a plus arithmetic progression. Okay, sum of n terms, right, can be given by what? Either n by 2 into first term plus last term, or n by 2 into 2a plus n minus 1 into d. So just make a note of these formulae, right? I think you would have seen this arithmetic progression in even 10th mathematics or something, but still we'll have to keep looking at these formulae one more time. Okay, so what is the formula that will be important for us here? It is the sum of n terms formula. Okay, now we'll go to the other type of progression, which we call as the geometric progression. So in mathematics you will learn about these three types. We'll generally have what? AP, GP, and then there will be one more type of progression called as what? Harmonic progression. Harmonic progression. But here and then if you are preparing for JEE, means definitely there will be something called as AGP and all that. Okay, but that and all is not relevant for us in physics. So what is the geometric progression? Geometric progression will be the common ratio between the successive terms will be same, which means what? Look at it, we have 2, then we have 6, then we have 18, then we have 54. So if you look at 2 into 3, 2 into 3 square, 2 into 3 cube, like this. Okay, so it is like what? AR square, AR cube, like this. So here the first term is a, and nth term, right, will be given by which formula? A into r power n minus 1. Nth term of the geometric progression is given by what? A into r power n minus 1. Ratio is more than 1. How do we represent? So we are not getting into the derivation of this formula in math, right? Plus 1 mathematics also you have, I think, sequence and series chapter where you look at the derivation of this. But here we'll just look at the result. What is the result? A into r to the power n minus 1 divided by r minus 1. This is what? The sum of n terms of a geometric progression. Okay, when we'll use it when the common ratio is more than 1. When the r is what? Common ratio, right? More than 1 means we'll use this. If the common ratio is less than 1, all that we are going to do is numerator, denominator, right? Numerator r power n minus 1. We can write it as what? Minus of 1 minus r power n, like that we can write. Denominator r minus 1 can be written as what? Minus of 1 minus r, like that we can write. So we can see clearly minus minus will cancel off. So what is the form we are going to get? We can write the same expression as what? A into 1 minus r power n by 1 minus r. What is the difference between the first and second expression? There is no difference. The only thing is here we are putting, the r minus 1 and r power n minus 1. In the second expression we are using what? Just reversing the expression. Both numerator we are reversing, denominator also we are reversing. Okay, so that we can see that this is like what? 1 minus r. Since r is less than 1, right? 1 minus r makes sense. R is more than 1 means r minus 1 makes sense. That is the only difference, the way we represent. But the formula is as it is. Okay, so this is what? Sum of n terms of the geometric progression. This is also something that we will be using. Okay, even we can use it in center of mass calculation and some moment of inertia problems also we may use, but we can also have questions in gravitation and electrostatics based on the geometric progression. Okay, but more than the sum of n terms of geometric progression, right, this is also sometimes important for us. What is it? The infinite geometric progression. Infinite geometric progression means what? Like if you have the geometric progression ar square, like that, we have infinite number of terms. Now when you have infinite number of terms, right, the sum of the terms will be meaningful only when the common ratio is less than 1. Why only when the common ratio is less than 1 is meaningful? I'll just tell you. If say for example common ratio is more than 1, we'll take the same example that we discussed, right? 2, 6, 18, 54, like that. You have infinite number of terms. Add all of them, how much you are going to get? You will simply get infinity. If you add all of them, right, what are you going to get? We will get how much? Infinity. So what makes more sense is when we have we are having what? When we are having the common ratio which is less than 1. If the common ratio is less than 1, right, what is going to happen? I'll just give you one typical series. So let's say for example we have the first term as 1, second term as 1 by 3, third term will be 1 by 3 square, fourth term will be 1 by 3 cube. So here what is the common ratio? If you look at it, right, it is like what? A into r. A is 1, so r will be what? 1 by 3. So when the common ratio is less than 1, right, the sum of the infinite GP, sum of infinite GP value, here also again we are not getting into the derivation. The sum of infinite GP value will be equal to what? First term divided by 1 minus geometric ratio, which is what? First term is A, divided by 1 minus geometric ratio means what? 1 minus R. So this will be what? We can say S infinity. What we can say? S infinity. And when we are going to use it? We'll use it when we have infinite GP with common ratio less than 1. Common ratio more than 1 means this doesn't make sense, right? Because we know simply if the numbers are increasing means they will, we have infinite numbers, right? The final number is going to be what? As high as infinity. So when you add all of them, we are going to simply get infinity only, right? That is it. So this formula is for what? When we have infinite GP with common ratio less than 1. Okay. So if you have any doubts, you can keep asking guys in between. Okay. So these things we have to be careful. Okay. Now we'll look at one sample question on this. Look at this. Find the sum of progression 1, 1 by 2, 1 by 4, 1 by 8, like that. They are saying it is in up to infinite number of terms. That way they put infinity. So this is like what? We have to put sum of infinite terms. We know only one formula, right? What is it? Geometric progression. Let us check if this is geometric progression or not. Can we check it? So this is like A. Second term is like what? A into R. What is the common ratio here? Half. Third term is like what? A into half square. Fourth term is what? A into half cube, isn't it? So what are we saying? This is like an infinite GP, isn't it? What is the first term value? A is equal to 1. And what is the common ratio? Half. What is the first term? First term is what? 1. And what is the common ratio? Half. Okay. Now we can check and tell it, guys. What is the sum of infinite terms formula for a geometric progression? This formula is when? This formula is when the common ratio is less than 1. This formula is when the common ratio is less than 1. Correct? So check it, guys. I am waiting for your answers. Just straight formula, right? What is the value? A by 1 minus R, right? What is the common ratio value? A by, sorry, what is the sum of infinite number of terms formula? A by 1 minus R. So here the sum of infinite number of terms, right? S infinity, that is what we can write it, right? A by 1 minus R. What is the first term value? 1. Common ratio is what? Half. Substitute. What we are going to get? 1 divided by 1 minus half. What is 1 minus half means? Half. So 1 by half means the 2 will go to the numerator. Check it, guys. What will be the answer for this? What will be the answer? It is going to be what? 2. I'm yet to see the responses over there. So I'm assuming you are able to get the answer for this. It's a straightforward thing, right? So this one we have to remember, sum of infinite GP when the common ratio is less than 1. Okay. So just to quickly summarize, right? If you have an AP means sum of n terms formula is what? N by 2 into 2a plus n minus 1 into d. That is the formula. GP means a into r power n minus 1 by r minus 1. Okay. This, you know, we can write in another way also. What is it? A into 1 minus r power n by 1 minus r. This we will use when r is more than 1. This we will use when r is less than 1. If the r is less than 1, for infinite GP, like the one that we are seeing in this problem, what is the formula for sum of infinite number of terms? It is what? A by 1 minus r. Okay. So I'm assuming we are able to get the answer. I can see Sudhen, you got the answer. Okay. So we'll move on to the next one, guys. The other important thing, right? We'll keep seeing this number E. E is basically what we call as exponential constant. So what do we call this E as? It is exponential constant. Okay. We'll use this E in various places. But what is this exponential constant? It is a number which cannot be represented as P by Q form. Okay, so P by Q form means what do we call it as? The rational numbers, right? Whatever the number that we are able to express in the P by Q form, we will call them as what? Rational number. So E is actually irrational number. Okay, and what is this value of E? E will be 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, like this. How many terms? Infinite number of terms. What is 1 factorial? 1. What is 2 factorial? Remember in the previous class we were discussing, right? 2 factorial means what? 2 into 1, which is 2. 3 factorial means what? 3 into 2 into 1. That is 3 factorial, correct? Which is 6. Next 4 factorial means what? 4 into 3 into 2 into 1, which is what? 4 3s are 12, 12 2s are 24, like that. If you look at what will be the value of this number, right, it will be what? 2.718, and this is going to keep on going up to never ending. So this is going to be what? Never ending, non-repeating. So it will be what? A never ending, non-repeating number. That is the reason why we cannot express it as what? P by Q form. Okay. So the exponential constant, right, we will use it in various situations, like, you know, particularly in physics, right, we are going to use it extensively. Even chemistry also you will be using it. Okay, but what is the approximate value? Mostly we will not be required to substitute the value, but if at all, right, in a particular case we have to substitute, means what is the value of E? We must take it as approximately 2.718. we are taking the value up to 3 decimal places. Maybe you can just make a note of it. E is equal to what? 2.718. But while we have the e value as such, right, we also have what we call as exponential series. Exponential series means if you have e to the power x, x can be any number, x can be 2, x can be 3, x can be 4, whatever it is. E power x will be equal to, this is the exponential series, e power x will be equal to what? 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. You know, I'll tell you one easy method to remember it. This is like what? This is starting from the 0. I'll tell you how we are going to start from 0. Okay, look at it. This 1 also, right, can be written as what? X power 0 by 0 factorial. What is 0 factorial? Yesterday we saw 0 factorial will be taken as what? 1 plus power of x will raise. Denominator also will be the next number factorial. X square by 2 factorial. So whatever is the power, same number factorial will come. X cube by 3 factorial, like that. So this is what is our e power x. If you don't want to represent it as x power 0 by 0 factorial, means we can put it as what? 1, like that. Okay. Otherwise we can also write it as what? X power 0 by 0 factorial, if you want to remember it. Okay. So this is what is the exponential series. Now if we want to look at the value of x is equal to 1, substitute the value of x is equal to 1, you know what you are going to get? Simply we are going to get the expression for e. You can check it. Here you to put the value of x is equal to 1. This is 1, this is also 1, this is also 1, because 1 square is 1, 1 cube is 1, like that, right? So you see what you are going to get? We will get the value of e, that's it. And while we have e power x, if we want to have e power minus x, remember last class also I told you, we are not going to remember multiple series. In a particular series kind of expansion, we will not remember each and every expansion. If you remember e power x means, what will be e power minus x? Replace, how do we get e power minus x? Replace in the entire series, right? Replace x with minus x, that is it. We'll have to replace x with minus x. Then we are going to get what? We will be getting the e power minus x expansion. Okay. So check it, students. So what is it? What is e power x value? 1 plus x by 1 factorial plus x square by 2 factorial, like that, right? In place of x, we have to put minus x. See, 1 plus minus x by 1 factorial plus minus x square by 2 factorial plus minus x cube by 3 factorial plus minus x power 4 by 4. So wherever we have x, we are going to keep minus x. Now the thing is, here in the second term we will have minus x, but look at the third term, minus x, we are doing a square. If you do square means what is going to happen? Minus into minus becomes plus, right? So look at it. What will be e power minus x? Expansion is what? 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial. Again, I will not recommend you to remember this. Just remember e power x, that's it. And what is it that we are going to keep in mind? If you want to change means, whatever the replacement. See, it is not just about getting e power minus x. Tomorrow suddenly while solving problem, right, we may have to do this expansion, I'll tell you. Okay, so we may have to do this expansion of e power, let's say we have to write e power 2x value, the series we have to write. What we are going to do, you know, we remember e power x. What is e power x? 1 plus x by 1 factorial plus x square by 2 factorial, like that. Wherever we have x, replace x with 2x. That's it. If you want to write e power x by 2 expansion, what we will do? Replace x with x by 2. So whatever the modification, right, in the entire series we are going to replace it. Okay. So this is how we are going to look at the e power x expansion. Okay. Next we will go into what we call as logarithmic series. Now, you know, after some time we will discuss about the logarithmic function also. We will discuss about the logarithmic function, but here what are we looking at? We are looking at the logarithmic series. Just like, you know, we have trigonometric function, sine, cos, we have trigonometric function, right? We also will have a trigonometric series also will be there. For sine x, we can have a series. For cos x also we will have a series. It will not be like this, but it will be similar to that. We'll have a different set of terms. Okay. So what is the logarithmic series? When we understand logarithmic function, we will be able to look at it in even more better manner. But here, no, we just look at it like in series. Log, just think of it like a function for now. Okay. Log of 1 plus x. So this logarithmic expression, right? The part that is there inside the log is what we will call as argument. So we'll discuss about it when we go and look at the logarithmic functions. But this 1 plus x term will be called as what? Argument. And here below we are writing e. This part will be called as base. What is this e? The e that we saw just before, right? What is it? Exponential constant. What is this e here? It is the exponential constant. Okay. So if you have the log of 1 plus x, so this is how we'll read it. How do we read this thing? Log of 1 plus x to the base e. That is how we will read it. Okay, when you read it like this, what is that expansion? That series expansion will be what? X minus x square by 2. Here there is no factorial. Plus x cube by 3 minus x power 4 by 4 and so on. So what are we seeing here? Observe, there is an alternative plus minus. There is an alternative plus minus, isn't it? So using this, right, if you want to get log of 1 minus x, log of 1 plus x is what? Maybe you can just make a note of this series. Log of 1 plus x is what? X minus x square by 2 plus x cube by 3 minus x power 4 by 4. So second term, fourth term, all of them are being what? Negative. First, third, they are all what? Positive. Okay. Now in this, right, if we want to have log of 1 minus x, what we are going to do? Replace x with minus x. Now when you replace x with minus x, right, look at it. Odd terms are what? The power of x is odd. Even terms, the power of x is what? Even. So when you do minus x is a square, minus x power 4, the minus will not be there. Why? Because minus into minus is plus. If you do minus into minus into minus into minus 4 times means it will be again plus. So we will be having the minus appearing only in the odd terms, because odd terms they are having power of x as what? Odd. So which means only the odd terms, right? Previously in the log of 1 plus x, what is the odd term? It is all positive. But if you replace x with minus x means they are also going to become what? Negative. Look at this, they are also going to become what? Negative. All the odd powers of x will be changing sign. Even powers of x will not change sign. When you replace x with minus x, we can remember it like this, right? Only the odd powers of x will change the sign. Even powers of x will not change the sign. Which means what will be the expansion? Log of 1 minus x will be equal to minus x square by 2 minus x cube by 3 and so on. Again, like I keep saying, right, we don't need to remember this log of 1 minus x. The thing that we need to do is what? Just remember log 1 plus x. For every series, right, we will not remember so many values. We will remember only one base expression. Now, if you want to look at log 2, log 2 can be written as what? Log of 1 plus 1. Compare it. Log of 1 plus x, we have expansion. What is it? X minus x square by 2 plus x cube by 3, like that. In that, in place of x, we are going to substitute 1. Look at what we are going to get. Everywhere, x will be replaced by 1. What is it? 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. Okay. So, we'll see the value of this, right? When we go to the logarithmic functions, we will be able to see what is the value of this particular log 2. Okay. But this is what is the logarithmic series. What do we call it as? We will call it as what? Logarithmic series. Okay. Now we will move on to trigonometric series. Just like the way I was mentioning before, right? We know what is sin x. Like if you take a right angle triangle, look at an angle x. This is the opposite. This is the base and this is the hypotenuse. So sine will be what? Sine will be what? Opposite by hypotenuse. Cos will be what? Base by hypotenuse. So this is what is the trigonometric ratios that we will get from the right angle triangle consideration. But here what we are looking at is a trigonometric series. And the trigonometric series, right, will be used in mathematics, of course. But this will be also sometimes useful for us when we are getting the derivative formulae. Because in physics, right, we are going to use the derivatives. Derivatives will come from where? The idea of differentiation, right? So in the differentiation and integration concept, sometimes, if you know the trigonometric series, it will actually help us to get the answer fast. So look at what is the sin x expansion. It is what? X minus. So the way we will remember it like this. Sin x expansion, right, will have all powers of x odd. So what is sin x expansion? All powers of x is what? Odd. Okay, only odd powers will come. And like the way we have seen before, every time whatever is the power, same number factorial will come. But in this also, right, first term positive, second term negative, third term positive, fourth term negative, like that. So odd powers means what? X power 1 by 1 factorial. Second term will be negative. Minus, here we are going to get only odd terms. X cube by 3 factorial. Next is what? X power 5 by 5 factorial. Next is what? Minus x power 7 by 7 factorial. This is what? Sin x. Sin x case, we are going to get what? Only the odd powers of x will come. Okay, this is how we will remember it. Only odd powers of x will come. Whatever is the power, same number factorial will come in the denominator. And plus minus plus minus. Story of cos will be almost similar. But the difference is what? We take only the even powers of x, including 0. We'll take the even powers of x, including what? 0. Which means what? Look at it. X power 0 by 0 factorial. Like that it will start. X power 0 by 0 factorial. Remember, we already discussed it. 0 factorial means what? 1. First term positive, second term negative. Second term will be what? X square by 2 factorial. Third term will be what? Plus will come. X power 4 by 4 factorial. Fourth term negative, x power 6 by 6 factorial, like that. And this series is going to up to infinity. This is going to go on up to what? Infinity. Okay. So this is what is the trigonometric series. Okay guys. So we are seeing what? Sin x and cos x. I am even telling you how do we try to remember it. So sin means what? All odd powers. Whatever is the power, same factorial will come in the denominator. What is factorial? 5 factorial means what? 5 into 4 into 3 into 2 into 1, like that, isn't it? Cos means what? Only the even powers of x will come, including 0, starting from 0 actually. Whatever is the power, same factorial will come in the denominator. And in both sin expansion, cos expansion, first term positive, second term negative. Third term positive, fourth term negative, like that. Okay, so just try to remember it like this. And we come to the all important logarithmic function. See, the idea of logarithmic function, how do we get this log value? And some of the properties of the logarithms, right? These are required for us, especially when you're solving questions in the JEE level and all that. We will be required to have good understanding of the logarithmic functions as well as their properties. And when it comes to the board examination, right, you will be required to even know how to use log tables. In this session, right, we are not going to cover how to use log tables. We will take it separately. We will make a short video on that. Maybe you can look at it, but because the point is in JEE, right, we are not going to be given the logarithmic tables. If any logarithm value is required, right, they will be giving us in the question statement itself or in the information list. So we will need to understand how are we going to use the logarithmic functions and what are the properties. But before that, let us try to understand what is this logarithmic function itself. So what is this logarithmic function? If you have a positive real number a and there is a rational number m, there is a positive real number a and rational number m. If you have a power m is equal to b, like that, this is just like what we can say 2 cube is equal to 8, isn't it? In this, what is a value? A is equal to 2. And what is m value? M is equal to 3. And what is the b value? B is equal to 8. This type of expression, right? You know what we call it as? We will actually call it as the exponential form. What do we call it as? We'll call it as exponential form, like that. No, we can even think about various examples. 10 square is equal to what? 100. 10 cube is equal to what? 1000. Okay. 2 power 5. What will be 2 power 5? 2 power 5 will be how much? What will be the 2 power 5 value? It will be 32, right? Like that. No, 3 cube. What is 3 cube? 27. All these are what? Exponential form. That is what you call it. Now the same information, right, can be represented in another way, and that is what we call as the logarithmic form. Same information, we know 2 cube is equal to 8. Same information can be represented in another way. That is what we are calling as the logarithmic form. What is this logarithmic form? So look at it. A power m is equal to b. This information we are representing in another manner. What is this manner? In the logarithm, like I said, right, this b that we are having here inside the logarithmic function, we will be calling it as what? Argument. What do we call this b as? B will be called as what? Argument. And a is going to be called as a base. Remember, in the exponential also we have a base, right? Base is there, power is there. Base is a, m is what? Power. Okay. Now let us look at what is this logarithm. So how do we read this? First of all, you will read it like this: log of b to the base a, or with respect to base a, like that. Okay. And the value, right, will be equal to m. So what does it mean? How we are going to read this log function? So let us just pay a little bit more attention here. What are we basically saying? The same information, a power m is equal to b. We know a is the base, m is the power, and that is what we are calling as the exponential form of representation. Same information, we are saying we can use a logarithmic type of function. What is this? We are saying log of b to the base a is equal to m. You know, how do we read it? We will read it like this. The value of the logarithmic function, right, is base is a. How many times you should raise a so that you will get b? How do we read this log function? If you are asking log of b to the base a, what is it supposed to give us? It is supposed to give us our power value. In the exponential representation, we have power value, right? It is supposed to give us that power value. That's it. We will look at the example. Say for example, you know, 2 cube is equal to 8. When we put log of 8 to the base 2, what will be the answer? 3. Why? 2. How many times we should raise so that we will get 8? How many times we should raise 2? Because 2 cube is equal to 8, right? Means the value of this logarithmic function, log of 8 to the base 2, will be equal to what? 3. What is the value of this logarithm? Log of 8 to the base 2 will be equal to what, guys? 3. Okay. So this is how we are going to read the logarithmic. Okay. I can give you a couple of more examples. We will just try to solve them so that we will get the logarithm idea concept. Okay. The logarithmic function as such, right, it is not a different function or different expression altogether. The same information that we have been using as exponential form, we will now replace this with a different type of representation. That's it. Okay. Now look at it. I'll give you a couple of log values, guys. You can tell me the answer. Log of 1000 to the base 10. I'm numbering them as A, B, C. When you're typing the answer over there, right, you also type it as A, B, C. Yeah? Then log of 64 to the base 2. Log of 81 to the base 3. So I'm expecting answers from you guys. You have to tell me what are these logarithmic function values. So in each case, right, the base is changing, isn't it? So first A, what is the base? Log of 1000 to the base 10. B, what is the base? Base is 2. Log of 64 to the base 2. C, what is it? Log of 81 to the base 3, like that, isn't it? So I'm waiting for your answers, guys. So what is this supposed to give us? How many times we should raise 10 so that we will get 1000? That is it, right? What is it? 10 power 3 will be 1000, isn't it? Which means if you raise 10 to the power 3, that is going to give us what? 1000. Which means what is the answer for the question A? What is the answer, guys? Question A will be what? 3. You have to check it. Question A will be what? 3. So once you get the answer, you can just type it over there. Now look at this. Log of 64 to the base 2 means what is the number to which we should raise 2 so that we will get 64. See, for here, right, we should have understanding of the exponential relation. Then only we can answer these questions, isn't it? So 2 power something. What is that power so that the value is equal to 64? Tell me, what is it? 2 power 5 is what? 2 power 5 is 32. 2 power 6 will be what? 64, isn't it? 2 power 6 is what? 64, correct? Which means the answer for question B is what? 6. Because 2 power 6 is 64 means log of 64 to the base 2 is going to be what? 6. So always remember logarithmic function, right? What is the value it is giving us? It is giving us the value of the power. In the exponential representation we see power, right? The logarithmic function is giving us what? The power value, that's it. So in logarithmic function we have the argument and we'll have a base. Base is same as the base in the exponent. And the argument is what? The value that you get from the exponential form. Okay. And logarithmic function value. Any logarithmic function value is going to give us what? It is going to give us the power. Okay. Now look at this. Log of 81 to the base 3 means we have to get how much we should raise the power of 3 so that the value is equal to 81. That is it. Always we will read the logarithmic function like that. What is the power of 3? 3 power 2 is 9. 3 power 3 is what? 27. 3 power 4 is what? 81, isn't it? Which means the answer for the question C is what? 4. What is the answer for question C, guys? It is what? 4. Why? Because 3 power 4 will be 81. Okay. I'm yet to see some responses, guys. So you have to type the answers over there. Then only I can see. Is it clear? So how are we getting these logarithmic values? So we will be able to get the logarithmic values when we have some understanding of the exponential relation, isn't it? Because this is nothing but a different way of representation. Same information we are trying to represent it in a different manner. That is it. Okay. Now the logarithms that we use, base can be anything. We have seen in question A, I gave the base as what? 10. Question B, we took the base as what? 2. Question C, we took the base as what? 3. We can use any base. But nowadays, right, we mostly use 2 bases. So these are the common values of base that we take. One is the logarithmic function with base E. Remember the logarithmic series that we discussed. There also we put the base value as what? E. What is this E? Exponential constant. E is what? Exponential constant. We have logarithms with base E. And the other type of logarithm is the one that will have base 10. So the logarithms with base E, right, they are called as natural logarithms. Logarithms with base E are called as what? Natural logarithms. We will also represent it as ln. So when we put it like this, lnx means what? Logarithm natural. We don't need to say that the base is E. If you are seeing something like this, right, ln ln x or lnx means what? It is telling that it is the natural logarithm. So what is this actually? Log of that number x to the base E. That is what it is telling us. Okay, this is one. And the other one is where we have the base as what? 10. So the logarithms with base 10, right, we will call them as common logarithms or decimal logarithms. Logarithms with base 10, right, what do we call them as? Common logarithms or decimal logarithm. Now one thing is important here, just keep a note of it. When we generally see, like we'll see log 64 without even telling any base, just we are seeing that log 64 means it is understood that this is decimal logarithm or common logarithm. Means it is understood that what we are talking about is log of 64 to the base 10. If you don't mention any base, and simply say log, it means what? It means we are looking at the base value to be what? 10. We are looking at the logarithm to be what? The common logarithm or the decimal logarithm. Okay. So this is a quick intro into the logarithmic function. So we look at some of the common logarithms. Log of 1 to the base a. Here a can be any number. Log of 1 to the base a. What is the value? 0. Why? You take any number a. Power 0 is what? 1. Any number like 2 power 0 is what? 1. 3 power 0 is what? 1. 4 power 0 is what? 1. Any number to the power 0 is what? 1. Which means log of 1 to the base 4 will be what? 1. Log of 1 to the base 5 will be what? 0. Log of 1 to the base 2 will be what? 0. Always log of 1 to any base. You take any base, right? The value is going to be what? 0. It means what? How much we should raise a so that we will get 1. Any number, power 0 will be 1, right? So that is it. And log 10 to the base 10 is 1. Which means what? How many times we should raise 10 so that we will get 10. How many times we should raise 10? Because 10 power 1 is equal to 10, right? Not only this. Log of any number to the base same number. Log a to the base a. Which means what? How much we should raise a so that we will get a itself. Means what? We know a power 1 is equal to a, right? Log of a number, base also same number. Then what will be the value of that logarithm? It will be what? 1. Okay. Then another thing, this one we are going to use when we will do the logarithmic conversions. When we are going to use it, when we do the logarithmic conversions. What is this logarithm? Log of 10 to the base e. What is this logarithm? Log of 10 to the base e. What is the value of this? 2.303. If you happen to see some formula, right, in physics or chemistry, especially in chapter like thermodynamics. In thermodynamic chapter, right, we are going to not only thermodynamics but even in some other problems like we will see in chemistry, you will see quite often like you will see this in chemical kinetics chapter in +2, like that you will see in many chapters the conversion. So what is the conversion we are talking about here? Conversion between the natural logarithm and decimal logarithm. We will see when we go there, we will be able to understand. What is this? This is nothing but what? The conversion factor is what we call it. What is it? Log of 10 to the base e. What is the value? 2.303. Just remember the value, we will use it. Okay. Now we will come to the logarithmic function properties. Logarithmic function properties. Okay. So we will just go one by one. So these properties, right, are important, not just in the mathematics point of view, but also in physics. And one of the important applications of the properties, right, is they can help us find common logarithmic values. One quick application will be what? Finding common logarithmic values. Okay, we will see once we cover the properties, right? First we will cover the properties. Look at the first property. What is it? Log of m into n to the base a. Log of m into n to the base a. The value will be equal to what? Log of m to the base a plus log of n to the base a. These properties, right? We will have to look at the property and then verify it with some example. So check it, guys. I am taking an example. Log of 10 into 100 to the base 10. Log of 10 into 100 to the base 10. This is what I am taking up. Here m is equal to 10, n is equal to 100, a is equal to 10. This is what I have. What is the property telling me? The value should be equal to log of m is what? 10 to the base a is 10, plus log of n is 100 to the base a. So this is my LHS part as per the property, right? This is my RHS part. What we will do is quickly we will check whether the RHS and LHS values are matching or not. Look at this, guys. What is our LHS? What is there inside the logarithmic function? 10 into 100. What is 10 into 100? 1000, right? So what we have? Log of 1000 to the base 10. I think already we did this, right? What is the log of 1000 to the base 10? 10 cube is 1000, right? Means what is this value? This value is what? 3. 10 cube is 1000, so this value will be what? 3. So this is our LHS part. Let's keep it. Let's look at RHS. RHS we have log 10 to the base 10. Remember, log of any number to the base same number. What is it? 1. Then log 100 to the base 10. What is 10 square? 10 square is 100. Means log 100 to the base 10 will be what? 2. Check it up, guys. What is it? 1 plus 2 is what? 3. LHS is 3, RHS is 3. So this is satisfied. Okay. So what is the first property we are seeing? Log of m into n to the base a will be equal to what? Log of m to the base a plus log of n to the base a. Okay. Now we will go into the second property. You have to keep noting down the properties. What is second property? Log of m by n to the base a. What is second property, guys? Log of m by n to the base a. What is this value? It is equal to log m to the base a minus log n to the base a. What is log of m by n to the base a? It is what? Log m to the base a minus log n to the base a. Now we will take an example and verify it. So look at it. Log of 1000 by 10 to the base 10. Again I am taking very simple numbers that we can easily verify. So here m is what? 1000. N is what? 10. A is what? 10. What is the property telling us? This is equal to log m to the base a minus, see when there is a division, what are we having? Minus. Okay. Minus log n to the base a. Now come back here, guys. What is our LHS part? 1000 by 10 is what? 100. So LHS is log of 100 to the base 10. What is log of 100 to the base 10? 2. Let's keep it. RHS. What do we have? Log of 1000 to the base 10. What is log of 1000 to the base 10? 3, isn't it? Because 10 cube is equal to 3. What is log of 10 to the base 10? 1, which is 3 minus 1. What is 3 minus 1, guys? 2 only. So our LHS is 2. RHS is also 2, which means what? This property is also satisfied. So log of m by n to the base a will be equal to what? Log m to the base a minus log n to the base a. Okay. Now from here, right, we will do one quick result. Using this property, we are going to do one quick result. And this is also something that we need to keep in mind. If you take, say for example, same log of 1 by x. Base can be any number. Let's not talk about the base. We can take base as 10 or e or any number. Log of 1 by x. Here look at this, guys. M is 1, n is equal to x. X is any number. As per the property, what is it? Log of m, which is log of 1 minus log of x. So what we are saying? Log of 1 by x is equal to log 1. What is log 1? Log of 1 to the base any value. Remember, log 1 to the base any value. What is it? 0. Because any number, when we raise it to the power 0, we will get 1, isn't it? So this is 0 minus log x. So what is it equal to? Simply minus log x. So look at this, guys. This is a quick result we are having. What is it? Log of 1 by x. What is it? It is equal to what? Minus log x. Log of 1 by x is equal to what? Minus log x. Okay. So just keep this in. So this is covering what? 2 properties. Now what we'll do is we'll go to the next property. Log of m to the power n to the base a. Log of m to the power n to the base a will be equal to the power right will come forward. N times log of m to the base a. We'll check it. Okay. So if you take log of 2 power 3 to the base 2. As per the property, what are we saying? The power will come here. 3 into log 2 to the base 2. That is it, right? That is what we are telling. N into log m to the base a. Now we will just verify it. LHS is what? Log of 2 cube means what? 8 only, no? What is log of 8 to the base 2? What is it? 3. Log of 8 to the base 2 is what? 3, because 2 cube is equal to 8. Now what about the RHS part? Look at the RHS part. What are we having in RHS part? 3 into log 2 to the base 2. What is the log of any number to the base same number 1? Which means what is RHS? 3. LHS is 3, RHS is 3. Both are satisfied. So what is the property? Log of m to the power n to base a. The power will just come in front of the logarithm. Okay, so this is about the third property. We'll go to the next property. So this is what we call generally as sequence rule. Okay, so what is this? This we call as what generally? Sequence rule. Okay, what is the sequence rule? If you just take a close look at it, right? What is the first logarithm? Log of x to the base y. Second is what? Log of y to the base z. Third is what? Log of z to the base a. If you have it like this, then the overall value will be log x to the base a. What is the relation here? See, in one logarithm y is coming as base, another logarithm y is coming as what? The argument. Y is coming as what? Argument. In one logarithm z is coming as base, another logarithm z is coming as argument. So essentially it is like what? When it is coming in base and argument multiplication, it's like, they are getting cancelled. So we cannot cancel them just like that, but the final result is what? Y is coming once in the base, once in the argument. Z is coming once in the base, once in the argument. Remaining is what? X is only coming in the argument. A is only coming in the base. It is like the final value is what? Just log x to the base a. Again, I am telling you guys, it is not like we are cancelling them, but the final result, right, will be what? Just like, the simple way we will think about it is what? It is like the number that is coming in the base and argument. When you have sequence or multiplication of logarithms, right, the number that is coming in the base as well as argument, that would not be appearing in the final value. So I'll just take one example to explain it. If you have log 4 to the base 2 into log 2 to the base 3 into log 3 to the base 5, like this we have. I'm just telling you, the final value will be equal to how much? Here 2 is coming in the argument, 2 is coming in the base, 3 is coming in the argument, 3 is coming in the base. Now the remaining part is what? So these two will not come in the final answer. This is sequence multiplication, right? Remaining is what? 4 is in the argument, 5 is in the base. This is what we are going to get. Okay, the sequence rule will be useful for us. Why are we focusing on the sequence rule? It will be useful for us in the logarithmic conversion. From where? From the natural logarithm to decimal logarithm or decimal to natural. Why we do it is because the logarithm that we are going to get, generally when we get the logarithmic function from mathematical operation, like we do a differentiation, integration, right, we are going to be getting the natural logarithm. Okay, and sometimes we will be required to convert the natural logarithm into decimal logarithm. We will be required to convert the natural logarithm into what? Decimal logarithm. Like say for example, we have a number of log. We have a log of a number x to the base e. This is what is our ln x, natural logarithm. By using this sequence rule, see how I am going to write it. Observe this carefully. I will write it as log x to the base 10 into log 10 to the base e. Can I write it? Look at it. 10 is coming in the base, 10 is coming in the argument. When you take them out, right, what you are going to have? X will be in the argument, e is in the base. So that is correct. So using sequence rule, natural logarithm of any number, x is any number, can be written as what? Ln x can be written as what? Log of x. Log means, remember what we said, generally when we say log, it is what? The common logarithm or the decimal logarithm. Log x into, what is the remaining part? Log 10 to the base e. Remember we talked about this value. What is this value? Log 10 to the base e. What is it? 2.303. Means what? Natural logarithm of any number x will be equal to log of x into factor. What is the factor? 2.303. So this is what is the conversion. So I'll just write it again at the top so that we can look at it like a formula. What is it? Ln of any number, natural logarithm of any number will be equal to what? 2.303 times log of that number. Log means what? It is the decimal logarithm or the common logarithm. Okay. So this is about the logarithmic conversions. What is it about? It is about the logarithmic conversions. Okay. Now what we are going to do is, we'll quickly look at the method of getting some common logarithmic values using the properties. So when it comes to JEE, right, this is what is important for us. So just knowing the properties is one thing, like, it will also help us while solving some problems, especially the problems where we are using this integration, differentiation, etc., right? That might help us. But if you look at the two common logarithm values that we'll keep using, right, they are log 2. Log 2 is 0.301 and log 3 is 0.477. These are the two logarithm values. Of course, we are talking about the base as what? 10 common logarithms. Now I'll show you how we can use the properties of the logarithm and get the remaining. So if you want to get log 4 can be written as log of 2 square. 4 can be written as log of 2 square. Remember the property, what is it? Log of m power n to the base a, what is it? N into log m to the base a, correct? Same property, 2 will come here. So what is it? 2 into log 2, which means what? 2 into what is log 2 value? 0.301, which is what? 0.602. That is whatever log 2. We can get log 5. That is what is log 4, sorry. Log 5 we can get. So what are the two logarithms that we'll generally remember? A log 2 value, what is log 2? 0.301. Log 3 is what? 0.477. Log 5, look at this guys. Log 5 can be written as what? Log of 10 by 2. Remember the property log of m by n. What is log of m by n? Log m minus log n. Correct. Log m is, what is the base here? Base is 10, right? Log 10 to the base 10, what is it? 1. Log 2 is what? 0.301. 1 minus 0.30 is what? 0.699. So what is the log 5 value? Log 5 value will be equal to what? 0.699. Okay. Now we will get the others also. Log 6. Log 6 can be written as what? Log of 2 into 3. This is like what? Log of m into n. Remember the property. What is log of m into n? Log m plus log n. Log 2 is what? 0.301. Log 3 is what? 0.477. So that addition will be equal to what? 0.778. That is what is our log 6. Log 7, right, we will not be able to straight away get by using the log 2 and log 3. Log 8 we can get. Log 8 will be what? Look at this. 8 can be written as what? 2 cube. Same property. What is it? Log of m to the power n. What is it? N into log m, that property, which means what? It will be 3 into log 2, which is what? 3 into log 2 is what? 0.301. That is going to be 0.903. That is our log 8. Then we can also get log 9. Log 9. 9 can be written as what? 3 square. 9 can be written as what? 3 square. Okay. So look at it. Same property. Log of m power n. Power will come forward. It is what? 2 into log 3, which is what? 2 into 0.477. 2 into 0.477. Okay. This is going to be what? It will be 0.954. 2 into 0.477 is what? 0.954 will come. Okay. So this is how we are going to get the logarithms, common values, right? We can get it. And in this, what are we doing? We are using the two common logarithms. What are those? We'll have to remember them. Log 2 is what? 0.3010 and log 3 is what? 0.477. Okay, these two things we have to keep in mind. Using that, you can see, right, In JEE examination, they might not give. Suddenly when you are solving a problem, we will get log 6. They may not give it. But we will be able to get the value quickly. If you remember log 2 and log 3 like that. Okay. So this is about the idea of logarithms that we are required to have when it comes to solving problems in chemistry or physics in general at the JEE level. Okay. Using log tables is a different segment. Because while solving problems for us in JEE, right, we will get logarithm value. Like, if you are getting, say for example, log 8 or log 9 like that, they will expect us to use these kind of an result derivation. But if it is something totally different, like, we are getting log 47, then they may give it in the question itself. Like they will say, use log 47 is equal to this much. Like that they will give us. Okay. So this is what we need to be knowing about the logarithmic function. And we'll continue the discussion in the next class. But just make sure that whatever the formula we are discussing, right, or the results we are discussing, you keep a note of it, because this is not like we are just discussing for one chapter or two chapters. These are the things that have to stay with us throughout the entire journey. I mean, from now till the end of +2 and probably the time up to which you will go and write the JEE advanced exam. Okay. So just keep a note of it, and we'll see in the next class. Any doubts means you can just type it over there. Otherwise, we'll wind up the class.